Welcome to today's webinar with the title We Systems, Bonding and More. I am Andreas Schilp, your host of today's Würth Elektronik Circuit Board Technology webinar, and I would like to welcome you. The speaker in today's webinar is a qualified specialist from Würth Elektronik, Matthias Niekrens from our Technical Project Management. Welcome, Matthias. And now I wish you lots of fun and new information.
Well, so also from my side, a big welcome. Thanks that you're here and that I can tell you something about our department. So like Andreas told you, it's about We Systems. It's a part of the PCB production of Shopfheim. At first, something to my person. I'm Matthias Niekrens. I have done a dual course of study here in Niedernhall in the PCB production. I finished the study in 2022, and then I changed to the department in Shopfheim. And since October of 2022, I'm the product manager for that area. So now it's around 2 years. For sure, when you have some questions, or I hope my English is well enough, so when you don't understood everything, please write into the comments so I can try to translate and explain better. So I think then I will start. The first question about We Systems, so who we are and what we do. The main technology here is the bonding. For sure, now you maybe ask what does bonding have to do with the PCB production. So this area in the past was a supplier of the PCB production in Shopfheim. And we have buy this area with this main technology, and we are growing over the past years. We're getting bigger. We are thinking about what we can do for future, whatever. So then also we get a part of the systems. So system, it means that we try to build and produce whole electronic parts, modules, whatever. So we don't want to do only the bonding thing with die bonding, wire bonding, whatever. So we try to give the customer the chance that he can get the whole product out of one hand from us. So that's the topic for the presentation today. Here I will tell something about our technologies, what get done in our department. I don't go that deep into the technologies. So because I want that you understand what we are doing, and when you need some more deeper informations about something like the die bonding, wire bonding, then write in the comments or give me a call or an email, and I can try to answer everything. So at first, our main topics: the die bonding, wire bonding, and globe top. That's where we're coming from. And so also the wire bonding we're doing with aluminium and gold. Then the next steps, what is going more into the systems, is that we are doing component assembly. So different things with putting things together, gluing, soldering, and so on. So that's also the next point with the manual and automatic soldering. Then for sure we're doing manual assembling from SMD and wired components. Here's some important thing for me. I will tell more later, but we are no normal and big assembler, so you don't find some machines in our production to do that. So we're only doing assembling projects for special things, for small quantities, and with handwork. That's it. Then also we're doing 3D printing if it's necessary. And then here you can see the other steps we try. So when we say we want to produce some system for you, we also want to manage everything. So with consulting, the process development of the production steps, and everything we're doing for prototypes, for serious production. That doesn't matter for us. Everything you want, you will get from us. Also in the end, we can do the customized packaging, and everything with the ISO 9001 certified. Well, so that are the main topics you will hear here in this presentation. For the next step, I will give the presentation back to Andreas. So see you later.
Okay, so we have a poll. We are interested in your functionality or in your work, what you are doing. If you are working in PCB design and development, or maybe purchasing or production, or are you a student or pupil? So that's what we want to know, and I will start the poll now. You should see a blue screen with 5 options, so choose one of them. And afterwards I will show the result out of this poll. So we've got nearly 80% participation, which is very good in this short time. I will wait some more seconds, then we will see the result. So in the German session, we also had participants working in purchasing. But today in the English session, that is not the case. So I close the poll and show you the result. So we have 79% in PCB design or development, none of you working in purchasing, 7% in production or production planning, no one is student or pupil, and 15% others. So in the question field, I can see there is one participant working as a product owner. Okay, so thank you very much for this information. That's it with the poll, and I give back to Matthias for the presentation.
Okay, thanks, Andreas. So then we will go on to the next slides. At first I will start with the first topic, the die bonding, so the fully automatic precision loading. At first, for the question, what this technology is about. So you can say it's about the generic term of the process for a permanently connecting of semiconductor chips to a substrate. Here, the substrate, it doesn't matter for us. So it can be a PCB substrate on a gold pad, on a solder mask, or also on ceramic. So here we are flexible. The most common die bonding technology is the adhesive bonding technology. So that's also what we are doing in our department. Other technologies would be the soldering or welding technologies. So I don't go deeper into the other technologies, so we will stay with the adhesive one. And for first, I will show you some video. It's from the hacker automation. And we're also having our machines from this supplier. And then I will start. And you can see how the machine is picking up different tools. And then from the different kind of packaging where the dies are on, so like waffle packs or the wafer, so the big round thing in front you can see. Yeah, so that's a normal process, how it is working. Here on the next slide, I will show some more about the process. So yeah, like I told you, the substrate, it's flexible, that is kind of yeah, PCB copper plate or whatever. You've got a chance that you can use electricity conductive or non-conductive adhesive. So that's yeah, decision is on you. You had to know how the die is working, that you want to get die bonded. Yeah. And you can put on the glue with dispensing or with a squeegee. Yeah, that's also something about the die, how it is working. Yeah, and then you get some pickup tool, what is with a vacuum. So here you, yeah, we have to be really careful that the die don't get damaged or something. So here we have to check at first how where the pickup areas on the die is. And in the most yeah, so most it's necessary to let produce some special tool from the yeah, machine producer. And then the position as accuracy is checked with a camera. So you also have seen that in the video before. And then if it's necessary, we can place the chip with a accuracy from 1 micrometer. Yeah, and the variable parameters are the amount of adhesive and the pressure with the chip get pressed on the substrate. Yeah, and there are also things with very small dies, whatever. Yeah, we had to be careful, and so you can, yeah, yeah, be careful with everything. The adhesive in the end had to cool it in the oven, so we do it with 120 degrees for 1 hour. So for sure, here you see that the process is not as hot as the soldering process. So it's yeah, better for the chip and for other parts on the substrate. Yeah, so here I will tell you something about advantages over soldering of the die bonding processes. It's a simpler process requirements, so because yeah, you don't have the soldering and you don't have the temperature you need for the soldering, and also for example the yeah, maybe you know the flip chip bonding. So here you had to put solder paste on the back of the chip, what is really difficult. Yeah, and so that's the thing why the gluing process is better with the cost. So it's better with the cost efficiency. Yeah, your flexibility in the application is better than with the solder process. Also, the thermal and mechanical decoupling is better. So that means, for example, with soldering, it's the heat flow is better like with the glue, and when you yeah, want to save the die from the heat, then it's better to glue than with the soldering, and also with mechanical decoupling, because when you're having big powers on the substrate, vibrations and so on, the vibration is getting better to the die when you have bonded, when you have soldered, than when you have glued everything. So yeah, here it's also better with the gluing process. Also, the last point, the simple integration of electricity insulation or conductive properties. Yeah, because you have the possibility to say you want to try use non-conductive glue or conductive glue, and with the soldering, this yeah, is not possible. In the end, the last point is the repair option. So that means when you, for example, have some a die on a solder mask, it's possible when the die is broken or something, you can put the die down, scratch the glue away from the surface, and then you can try a new die. So that's also possible. Yeah. Then the next technology is the wire bonding. Here, for example, you can see some project on the right from us. So here we're having a die and with around 400 wires around the die. Yeah, and here we're having the wire connection between carrier material and semiconductor. Yeah, usually with aluminium or gold wire. Also possible are wires like silver, copper, and some more. But in our department, we're normally working with gold or aluminium. But that's for sure something if the customer said he need some different, yeah, we can talk with each other and then have a try with other things. Yeah, that's no problem. Then you normally have the thin or the thick wire bonding. In our department, we classically use the thin wire bonding with 25 micrometer diameter. But that's also the thing. So that's more because the customer wants the 25 micrometer. If you as customer come to us and say, hey, I need something different, yeah, it's also no problem and we can talk about it. Yeah, so this is some technology with visually and electrically verifiable contacting option. So on one hand, you can have a look, an optical look on the wires, that the wires maybe are broken, or for example, it's very important that the wire don't have contact to each other because it would destroy everything. And also in the end, it's possible to do in the end a test, a functional test of the whole group. Yeah, where you can see that it is well or not. Yeah, and you will find wire bonding in the chip-on-board technology, power module technology, high frequency technology, or in the assembly of microsystems. Yeah. Okay, so then I will talk about the gold wire bonding. So it's called also thermosonic bonding or ball-wedge bonding. Yeah, I think you will understand what the name is meaning when you see the picture here. So on the left, you've got this gold ball, and then on the right, you see this wedge. Yeah, so that's typical for gold wires. Sometimes also you use some safety bomb. That would mean that on the wedge here on the right, you've got some ball what you're putting on it for a better yeah, wire bonding process. With this process, you have to heat the substrate. So on the right, when you have a look here on our Enerpic substrate, this yeah, substrate is heated up to 80 to 180 degrees. Yeah, that is something we have to look from part to part. Then for sure it's an automatic process. What does mean? You program at first the wire bonding program. So from our customers, we will get some bonding plan. And with this plan, we are writing the program. And then when everything fits well, you just have to start the program. Then the wire bonding is getting done. And after that, you have to put out a substrate and put in new substrate. Then the geometry of the bonding wire can be customized. So yeah, when there are things like I don't know, maybe from in the past with some project, a customer told us that bonding wire, the height of the bonding wire is important because the module will go into some building where the high is not that much. So when the bond wire would be too high, it would have a contact. So yeah, here you have to the option to customize everything. Normally, like I told you, we are using the 25 micrometer wire, and for that we normally need a bonding pad with a 100 micrometer size. Yeah, so if it's also smaller, it's possible, but for us it's more difficult for the whole process. So because the process is working with a camera system, and when the pads are too small, then it's more difficult for the machine, for the bonding machine to find the pads. So in this case, then the colleague from us, what is working with the machine, had to have a look on the camera and then help the machine that is working again. So for that, yeah, it's possible, but it's more difficult for us. And normally we need anepic surfaces on a substrate to do the gold wire bonding. Yeah, so that's also the important thing. Here we've got some charts from the process, like you can see here. So at first we had to do the melting of the gold ball. This is getting done with electricity. In the next step, we're doing with the ultrasonic power and bonding force. We put the gold ball on the surface. Then with the wire we have programmed, with the geometry we have programmed, it is going to the next pad, and there we don't have the ball again. So yeah, here we have a wedge what is getting built. Okay, so here in the next step, I will tell you something about aluminum wire bonding. In this case, it's called ultrasonic wedge-wedge bonding. So with no balls, only wedges, and because of the ultrasonic power, what is necessary, that it is bigger than with the gold wire bonding. Yeah, we've got a name here. And at first, also, I will show you this video. Yeah, and I think you will have seen how thin the wires are. So just for example, a human hair is around about 70 to 80 micrometers. So with 25 micrometer, it's less than the half from that. And then here it's also like with gold wire bonding and an automatic process, just with the difference that we don't need some heat generation. That's because the missing bump, so or the ball, and because of that it is done with the ultrasonic power. So also the same here. So the geometry of the bonding can be customized. So the only thing is that it's not possible to do geometries like with gold, because aluminum is a little bit more stiff. Here the same like with the gold wire bonding. So we're having the 25 micrometer wire with a 100 micrometer wire pad, smaller as possible for sure. Then we're doing the aluminum wire bonding on Enik surfaces. Yeah, for sure also surfaces from copper, from aluminum, or whatever would be possible. But with the Enik, yeah, that are the best results you will get. Also, here's some slides about the procedure from the aluminum wire bonding. So yeah, like you see here, we don't have the ball, so it's just a wedge from the one side to the other side, and then with the tear off of the wire, and it's finished. Here a little comparison about pros from every technology. So for sure with the gold wire bonding, you've got better heat dissipation, electrical conductivity, higher corrosion resistance, also lower mechanical forces. So that's very important when the dies are very small, or you have to be careful on the surface to don't destroy or break something. And also because of the material and the technical, it's you can get a higher precision with the gold wire bonding and also smaller geometries. Yeah, the aluminum wire bonding, slightly lower cost for the overall process. So for sure, at first because of the material, we are using, then also because of the missing heating. Yeah, then the aluminum wire bonding is more robust. What is meaning, yeah, for some products maybe this is better, and it's in the end it's a less complex process than the wire bonding process with gold wire. Yes, so then here we've got a globe top. What is for the protection and stability. On the right, you can see some of our products. So yeah, what is a little bit blue here, you can see that's some ceramic. On the top of the ceramic, we're having some dye. And then also with the wire bonding, and to protect the wires and the dye, we have put on the dark globe top. So on one point for the mechanical protection, then also for the electrical protection, because the globe top normally is non-conductive. Then also protection from environmental influences like heat, cold, wet, whatever. Yeah, then also the heat dissipation. Then number 5 is important, for example, for the process you have seen on a later slide with the die with around 400 wires. So because it's important that the wires don't touch each other, and then you use the globe top also for the stabilization, that they don't can move or something. Then you've got different potting options. Yeah, the first one is the full grouting, what means you put the globe top over all you have seen. So the wires, the different or the dies, also for SMD parts, whatever. So here we are also flexible. The next one would be the spot grounding. So that means that you can just put the globe top on special spots like you have seen on the other picture. Also possible is the dam and fill. What means that in the first you put some dam around the area, and then you can put the glue or silicone or exposi or whatever you put into the dam. So like that. Then here I've got some different potting materials what are normally are used in for the globe top. In our area, we are working with epoxy resin and silicon. Yeah, so the different, normally for sure epoxy is with a high strength and mechanically stable. So but for example, when you've got some substrate with high vibration or whatever, it would be better to use silicon because it's flexible. Yeah, then also vibration damping. Yeah, so here you have to have a look for every product where what is better for it. Yes, so this is our I think first point from the systems. What means yeah, we're doing individual assembly and joining work. Here it's like you see on the right with the gluing and filling. So on the right module, you can see that we have put some glue into the copper ring, and then in the next step, we are putting a shield into the copper ring. Yeah, and also we're doing then things like soldering, welding, yeah, putting things together, whatever you want. Here with the soldering process, yeah, like it's getting hot, we can, or we have the reflow soldering. We have also the hand soldering. Yeah, and also then the automatic soldering. So here that was one example from our biggest customer. At first it was just something about prototyping, and then in the end we're having a really big series production. Yeah, and then we say maybe it's better for the quality and also for the quantity of parts we can produce, that we do this process automatic. Yeah, and then with the help from some supplier, we have developed some soldering machine. Yeah, and that are also things we do. So try to work together with the customer. That's some important thing what I told you before. So yeah, we are no classic assembler, and yeah, that's not now, that's not tomorrow, also not in future. So for sure we're having big assemblers as customers in the from the PCB production. Yeah, and that's not what we want to do for our future. So larger and more complex assemblies are getting outsourced to providers, external providers. So yeah, we're doing it, but not in-house. So it's then yeah, out-house. So we're doing the manual assembling for kind of special assemblings for small series and prototyping, and everything is getting manual. So yeah, with a lot of handwork. Yeah, and also we're doing it with stencil printing or dispensing. Here some example from our 3D printer. Yeah, here also we are completely flexible. So on one hand, we can print assembly components, or like on the right, you see some returnable packaging. Yeah, we have created for our customer, and it's also possible to do that with various materials. Yes, and here that's, yeah, should be the process of when we work together with the customer. So we say you have to develop the product, and we will develop the process. So for sure, at first the customer yeah, needs the idea of the product, and then it's that we are doing step by step the whole process steps together. That we are doing all the time the loops to develop the process, to develop the product, to optimize everything, and in the end, it's yeah, we would like to get from some first idea to a serious production in the end. Yeah, so from the product idea to serious production. Yeah, and we offer customized solutions for small, medium, and serious production. So yeah, it doesn't matter what kind, we will try everything. Yeah, so here also the thinking about everything from a single source. On the right here, you can see some example for the whole production steps when you would like to get some electronical module or whatever. Yeah, so with the beginning in the PCB design over PCB production, yeah, die bonding, wire bonding, and then in the end with the shipment to customer. And so it can look when you do it with we systems. What is meaning for the whole production steps, you've got one person you have to talk to. And sure, for sure, we don't doing things like PCB design or PCB production in our department, but yeah, because we are yeah, we're working together with the PCB production. We have a lot of colleagues, we have a lot of experts everywhere. So I also can do the organization for the PCB production. Yeah, and in the end, you've got just me as your person you have talked to, and you will get some whole product. On the other hand, it could be look like this when you do it with other suppliers. Yeah, for example, here it would be 6 suppliers, so 6 times with talking rounds, with organization things and everything. Yeah, so I hope that you can see the different. Yeah, and that's what we want, so that we can say from the printed circuit board to the complete end product assembly of your complete system. So also we are doing things like the distribution, the coordination of service providers, materials and provided parts. And yeah, I would say everything you want. We can have a talk and then we will see what is the best solution for everyone.